picture. If quantity required is greater than quantity on hand, we call wait. Now what exactly does the wait method do? It puts the thread, the consumer thread, into a wait pool by releasing the lock on the object. So it releases the lock and goes to the wait pool. So now the producer thread can access a lock to call set quantity on hand, produce the quantity on hand required, whatever it is, and then it calls notify. When it calls notify, it wakes up the thread which has gone to a wait state, that's the consumer thread. Once it releases the lock and comes out, now this consumer thread which was in a waiting pool, which has been brought back into a running state via notify, gets the lock again to get the quantity on hand. So quantity on hand minus quantity required. So this is where wait and notify is very useful, or different from your sleep or suspend methods. If you call suspend, we said we need to call resume. We said these methods have been deprecated. Why? Because if I call suspend, I go into a sleep state holding the lock, so no other thread can access the method also till a resume is called. Whereas in case of wait and notify, these, in order, if I have called wait, I have to call notify also. Now you can say it's the same case as suspend and resume. If I don't call notify at all, but I'm not holding a lock on an object. I've released the lock and then gone to a wait state till notify is called. But then I also have an option with the wait, that is I can specify how long it can be in a waiting period in the wait pool by specifying wait of milliseconds. So in which case, either the thread will be in the wait pool till the specified amount of time or till the notify is called, whichever one comes first. So the same case has to occur with another thing with the deadlock here is, let's assume that the consumer thread which had placed a lock and found out that the quantity required is greater than quantity on hand, called the wait method, goes into a wait pool. By the time the producer could come in to set quantity on hand, you have another consumer thread which calls the get quantity on hand. So places a lock, comes in and checks whether the quantity required is greater than quantity on hand. It also calls wait. So now you have more than one thread in the wait pool. Now when the producer gets to lock and call the set quantity on hand and he calls notify, which thread will he notify? Because there is more than one thread in the wait pool. The thread that it notifies depends on the implementation of the JVM. You can't really say which thread actually gets notified. It could be the first thread, it could be the last thread which went into the wait pool, or it could be the highest priority thread. Most often the JVM implements it as the first thread which goes into the wait pool is the first one to be notified. Why? Because if assume that I notify the last thread which got into the pool, the first thread might end up waiting for a long period. The same case might happen with the highest priority thread also. So therefore general implementation would be the first thread which goes into the wait pool gets notified first. Again, in general, to answer this question, which thread gets notified, you are not sure. It depends on the JVM implementation. There is a notify all method as well. Instead of calling notify, we can call notify all. In case notify all is called and multiple threads are in a wait pool, what happens is all the threads are notified, so all of them come back into a running state. So which one gets the lock first? It's the highest priority thread that gets a lock in case of notify all. So that's about the wait and notify and the notify all methods. Now one more point is that wait and notify all methods must be invoked in a monitored area. Otherwise we get illegal monitor exception, which means to say these methods must be called within the synchronized blocks, or if you were to call these methods in a non-synchronized area, the non-synchronized area must always be called through a synchronized area. Otherwise we get an exception. That's another important point. Wait and notify should always be invoked within a monitored area. So this is the difference between wait versus sleep or suspend. Again, sleep method also goes into a sleep state by holding a lock. It's only the wait method which releases the lock and goes into a sleep state. So this is how you take care of deadlock situations during synchronization process.